This video is to accompany the Cisco Netacad IT Essentials 7.0 course. This video covers Chapter 5, Networking Concepts. In Chapter 5, we're going to look at network components and types, network protocols, standards and services, network devices, and network cables. Network components and types. When you're working with Packet Tracer and with Cisco, you're going to need to be familiar with some of these types of networking icons, such as a switch, which is a box with arrows going back and forth, access points, wireless routers versus a router. A router is just a cylinder here. The wireless will have the antenna on them. Desktop computers, tablets, iPhones, the media icons, LAN media, just a black simple line versus a WAN media versus wireless. When we're talking about topologies and their descriptions, some of the most common topologies that you'll be working with, the first one is PAN, Personal Area Network. Those are commonly, Bluetooth is a current at the recording of this video. Bluetooth is a common personal area network. It connects mice, keyboards, phones, tablets, earbuds, different types of devices. It allows you to connect to wireless speakers. There's all different sorts of connections that it can make, but usually very short range, very small, very limited number of devices make up the personal area network. The next one is the local area network. That's a wired network consisting of a switch and or a router, but usually a switch and a network device in a limited geographical area, usually like a classroom or a small office building. And then you have virtual LAN or virtual local area network. That extends beyond the traditional LAN, and it groups users based on administrative defined boundaries, such as a department or a floor. So if you wanted to segment off the sales group versus the accounting group versus the administrative group, you could do that with a VLAN. And then you have wireless LAN or WLAN. That connects multiple wireless devices and uses an access point. Another one is the WMN, Wireless Mesh Network. That connects multiple wireless access points together to expand the wireless network. You'll hear it called Mesh Network. A lot of times you won't hear wireless mesh network. You'll just hear Mesh Network. But that's usually that's a number of different access points, wireless access points that connect multiple devices across a larger area. And then you have MAN, Metropolitan Area Network. That's a network that spans over a city. A wide area network is a network that spans a large geographical area. And an example of a WAN would be the internet. The internet is an example of a WAN. That's a wide area network. And a VPN is a virtual private network. That's a method of connecting to a network such as a company or across an unsecure network or internally. So a virtual private network would allow you to connect from, if you have an unsecure network that you want to tunnel through. So you create a VPN tunnel, and let's say that you're a teleworker or a remote worker, you would log in through a VPN client, and that would allow you to go through the internet, and then your data would be encrypted on the way towards your location that you're connecting to. One of the historical connections to the internet is dial-up, or what we call the POTS line, P-O-T-S. And that was the plain old telephone service. Plain old telephone service. You may see that at some point, but that was analog. That used an analog modem to call another modem. You had ISDN, that was Integrated Services Digital Network. You may come across these in some more remote areas. If you're working, you just may come across those in ISDN. They can carry voice, video, and data. And then broadband, which is the most common now. That uses different frequencies to send multiple signals over media. A DSL is a digital subscriber line. I can't say that properly. Digital subscriber line. There we go. Always on technology that uses phone lines, voice and data carried on different frequencies, and it requires a filter on the port that connects to a phone. And then you have cable. That uses a cable modem to connect to a traditional cable TV network, and it shares the network with multiple subscribers. So you may have multiple users along that line in a neighborhood that are all using the same wire. And then you have fiber. That's high bandwidth connection used in backbone networks. Large enterprises use it, large data centers use it, and now it's part of some home internet connections that are being installed. Another type of connection is the line of sight wireless. That's an always-on technology that uses radio signals for connecting to the internet, and you may see these out in remote areas. You'll see some type of receiver, and they have to have line of sight to the tower, and they use radio signals to get that signal. Satellite is another technology. It's broadband technology for remote areas. It uses a satellite dish. It's not a good solution for time-sensitive applications like gaming, VoIP, voice over IP, or video conferencing because there is some lag in the signal going up to the satellite and back. Cellular relies on cell phone towers, or cell towers. We say cell phone, but cell towers to create a network used by cell phones and connectivity to the internet and other devices. But usually it's going to be some type of mobile phone that's going to connect to that cell phone tower, and then you can use data and voice and texting and other media to go across that connection. Now you can do mobile hotspot and tethering. It's a cell phone option that allows users to use their mobile device to connect to other devices using Wi-Fi, Bluetooth, or a USB cable. The other device is using this phone cell connection to connect to the internet. It's called tethering or hotspot. And a mobile hotspot's when a cell phone allows Wi-Fi devices to connect and use the mobile data network. You just have to be careful because some providers limit the ability to be able to tether or hotspot without charging extra fees for that. Networking protocols, standards, and services. One of the models that you will need to learn and be familiar with for this course exam and for the CompTIA A+ and the CompTIA Network Plus and the CompTIA Security Plus is the TCP/IP model. You need to be familiar with it. You have an application layer, a transport layer, an internet layer, and a network access layer. And some of the terms that you need to know for the TCP layer, we'll take a look at that first. But your application layer is your programs. So your web browser, you might have a web browser, you might have an email client. The web browser might be using DNS services. And then at the transport layer, we're looking at TCP and UDP. And TCP is a reliable, it resends lost data. UDP does not, but we'll take a look at that in the next slide. TCP has three basic operations of reliability. It allows for numbering and tracking of data segments. It acknowledges received data, and it retransmits any unacknowledged data after a period of time. So TCP is a connection-oriented protocol, connection-oriented, and that's important to know. UDP just does, I always think of it as it just doesn't care. It's got very little overhead or data checking. It's what we call a best effort. It's just, it does its, it just kind of, if it gets there, if it doesn't, I don't care type of thing. There's no acknowledgement that the data is received by the destination. And you may say to yourself, well, why doesn't everything use TCP versus UDP? Well, UDP allows for less traffic. So it's things like TV signals or video signals. If you're sending video, if you're doing two-way conferencing, if you're doing a phone call, you don't need to have every bit of data get there. For an email, you need to have everything there. You need to have everything. So you would use the TCP because every segment has to get there to rebuild that information. For a UDP, and for a phone call, voice over IP, or for a video, you can lose packets and still be okay. Now, you are going to need to learn some of the basic port numbers, some of the common port numbers, or what we call common numbers. And the World Wide Web or WWW protocols, some common ones are 53 port. That one's TCP and UDP, an application for DNS. So DNS uses port 53. HTTP uses port 80, which is your web browsing. And then secure web browsing or encrypted web browsing, encrypted connections use HTTPS, which is port 443. And then you got some other common ones, 25, Simple Mail or SMTP, POP3, IMAP, LDAP. And then for remote access and connections, you might have 22 or 23 for doing SSH or Telnet, or RDP uses 3389. 67 and 68 is for DHCP. NetBIOS uses 137 to 139. The Simple Network Management Protocol, or SNMP, uses 161 to 162. SLP uses 427. FTP uses 20. TFTP uses 69. SMB or Server Message Block uses 445. And Apple Filing Protocol, it's proprietary to Apple. It uses 548. Now, wireless LAN protocols, the protocols, the IEEE standards, these are standards that you will need to know for exams in this course and for the CompTIA A+. You may have an overview of them, but you'll definitely need to know them for the CompTIA Network Plus exam. You have the older standards, which was the 802.11.a. You probably won't see too many of the A and B anymore. You might come across a G standard or a G router still in service. Most common today are the N and the ACs, and then now you have the new 6 version, which is the ACX, I think it's called. It's just come out this last year in 2020, or been starting to be put into practice. But you can see the different speeds here. You need to be familiar with the speeds for the exams in this course. You do need to know some of the ranges and the frequencies and the backwards compatibility. For the CompTIA Network Plus, you're definitely going to need to memorize this information and have that ready for the exam. Now, some other protocols are Bluetooth, NFC, or near-field communication, and RFID, or RFID, radio frequency identification, but Bluetooth is the first one. You can connect up to 7 devices to create a PAN, personal area network. It works on the 802.15.1. Now, remember back here in our standards here for IEEE, 802.11a, well, these fall into the 802.15 one. And they work on the 2.4 to 2.485 gigahertz radio frequency range. RFID, it can be either passive or active tags. It can be most commonly used to identify items. Passive relies on an RFID reader to activate and read, and an active has a battery to broadcast the ID up to 100 meters. And it works in the 125 megahertz range to the 960 megahertz radio frequency range. And then you have near-field communication. This is used with a lot of like Apple Pay or Samsung Smart Pay or Google Pay. Near-field communication, you would use it off of your smartphone. Devices must be in close proximity, and I mean within like fairly close proximity, within at least I would say maybe 10-12 inches. Pretty close. It's used for payments, printing, public parking, things like that. Some other wireless protocols are Zigbee. They require a Zigbee coordinator to manage a client device and connect to a wireless mesh network. They're commonly managed from a cell phone app. And then you have Z-Way. That's a proprietary standard, but there are public versions available. And you can have up to 232 devices connected to a wireless mesh. Now, when we're looking at the cellular generations, 1G and 2G were the first gen. They could only make analog phone calls. 2G introduced digital voice, conferencing calls, and caller ID. And then you had 2.5 that supported web browsing, short audio, video clips. And then you had 3G, which would allow for full motion video and streaming up to 2 megabytes a second. Ooh, blazing speeds there. And then we had 4G, which is still fairly common in the United States. It allows for IPv6, IP-based voice, gaming services, high-quality media at multi-speeds up to 672 megabytes a second. So we went from 2 megabytes up to 672. And then you had long-term evolution. That just meant that it met the 4G standards. It improved some connectivity speeds while in motion. So if you're traveling down the freeway or in public transportation, it helped with that. And then it gave you speeds up to 100 megabits a second when mobile and up to 1 gig when stationary. And then we have 5G, which is currently being rolled out across the United States and in other countries as well. But that supports augmented reality, virtual reality, smart homes, smart cars, data transfer between devices, download speeds up to 3 gigabytes a second, and upload speeds of 1.5 gigabytes a second. Now, in the world of networking, you're going to hear some different terms. You're going to hear client and server. When we talk about client versus server roles, we're not necessarily talking about a network server, because you can have devices serving information. So there's actually 2 different terms that you need to be familiar with. Client server, but client server can mean just 2 devices giving information back and forth. So they can be in both in the client and server role, or you can be talking about a physical server doing some type of service, such as like a web server. So you have file client and a server, web client and a server, and an email client and server. So you might have a file client pulling up a web page, and so it would go through the switch and pull up the web server. So you have the server, but in networking, anytime you're providing services or providing information, you are in the server role. And when you're requesting information, you're in the client role. And then you have the more traditional clients that we think of as mobile devices or desktop devices requesting information from a server like a file server, email server, or web server. Now, DHCP that type of service provides IP addressing information. When you need IP addresses and you don't want to give them static out. So it creates a pool of IP addresses, and then when devices connect, it gives them an IP address so that they can connect to the network. DNS server, it translates domain names such as cisco.com to an IP address. So you would type in cisco.com or www.cisco.com, and it would translate that to an IPv4 address or an IPv6 address. A print server, it can control multiple printers. It provides client access to print resources. It allows a company or a business to have one printer. And so instead of having a printer at everybody's desk, you might have one printer for 25 people. And so 25, 30, 40 people can all print to one printer. And you can use the networking services to do that and have it in one location. It saves a lot of money because you're only supporting one large printer versus multiple small printers. A file server allows clients to access files using a specific protocol, either FTP, FTPS, secure FTP, or secure copy. So you can have files out on a server and you can request those. And so the browser, you might use a browsing service to connect to the server. And then in the background, when you copy those files across, you're using one of the other protocols to get those files moved across the network. A web server provides web pages or web resources using protocols of HTTP, HTTPS, SSL, and TLS, and TCP port 443 for the secure, for the HTTP. And HTTP uses port 80 and HTTPS uses port 443. And this is the more secure because it encrypts the data. A mail service is email messages that are stored in a database on a mail server, and the client requests to see what mail messages are there, and they will send them down. There's different protocols. You have a simple mail transfer protocol, SMTP, or POP or IMAP. And there's different ways that they pull those from the email server, and you cover this in more depth in other courses with the Cisco Academy. You have a proxy server that acts on behalf of a client, thus hiding the real internal host. It uses cache frequently accessed web pages. So if there's a lot of web pages that get pulled down, you have a proxy server and it stores cached versions of those so that the client doesn't always have to go out to the internet or out to the network and to the HTTP server. Let's say that it's pulling up there's images that are on this web page. The proxy server will store those, and then so the client, when it goes through, will actually pull those from the proxy server instead of going out to the main HTTP server. You have authentication server. Authentication, authorization, and accounting, or AAA, that allows access to a network device or a particular network. It establishes a connection with the router. The AAA router prompts the user for a username and password. The router authenticates the username and password using a remote AAA server, and the user is then provided access to the network based on information in the AAA server. You have syslog servers or system log servers. They store network messages sent by the networking devices so that network administrators can go back and look at what's going on with the network and see problems that are happening, or just, in general, what's going on with the network. 5.3 basic network devices. One of the things you'll need to be very familiar with in this course and the Network Plus and in basic IT in general is the network interface card, or NIC card. NIC, you'll hear it called a NIC card. They have either wired or wireless network capability. This is a card that you would plug into your PC or your personal computer, and it would allow you to connect an RJ45 connection. A wireless NIC, that would also plug in, but you would just have the antenna coming out of the back. Some gaming desktops will have these now, or they'll have them built in on the motherboard. You have a new USB NIC. These aren't super common anymore, but they are still around and you can use them. Some other terms that you need to know are repeaters, bridges, and hubs. Repeaters are also called extenders because they regenerate the signal so it can be sent further on. So let's say that if you have some clients that are a little bit too far from the router or wireless router, you would have a repeater in place and it picks up the signal and repeats it. It strengthens it or rebroadcast it so that you can then go to a further distance. A hub receives data on one port and sends out to all the other ports. And a bridge divides a network into two or more segments and tracks which devices on each segment. Switches, or Ethernet switches, record MAC addresses for each device that are connected to the switch, and data is sent to a specific device if the MAC address of that device is on the MAC address table. And managed switches are used in a company environment and have additional features. And unmanaged switches are used in home and small business networks. You have wireless access points, or WAPs. Or APs. You'll hear the term WAPs or APs, but they provide access to a wireless network for a limited range. Routers connect networks. Uses an IP address to forward traffic to other networks. They can be multi-purpose device. They can integrate an integrated router that includes switching and wireless capabilities. So you could have a router that has wireless capabilities, so wireless devices can connect, printers can connect, mobile devices can connect, and IP phones, and then it routes it out to a port or a gateway, and then it goes out to a remote area, usually using the internet or some type of network, and then it tunnels through and then goes to where you're pulling information. Firewalls. A firewall protects data and devices connected to a network, and the term of this comes back in buildings. In traditional, when you would put a building up, they would put a firewall in a building, and so if there was a fire on this side of the building, it would keep the fire from spreading, and that's where the term firewall comes from. Well, a firewall in terms of networking just means that you put up either a virtual or a physical firewall, and that protects the host from external threats. Firewalls use access control list, which are rules used to determine whether data is permitted or not permitted. An IDS and an IPS. An IDS is an intrusion detection system. It monitors traffic and is a passive system. It's passive. An IPS is an active system, but it's an intrusion prevention system, and it actively monitors traffic and takes action when needed. A UTM is a universal threat management. It's an all-in-one security appliance. It features vendor-specific, and it could or could not include firewall services, IDS and IPS, additional services such as zero-day denial-of-service attacks or distributed denial-of-service attacks, or spyware. It can also help with proxy and email filtering, network access control, and VPN services, just depending upon which device it is and how it's configured. You have endpoint management servers. An endpoint management server monitors end devices such as PCs, laptops, servers, laptops, printers, and helps in the management of those. You're also going to come across legacy and embedded systems. A legacy system is a device on the network that's no longer supported, but it is still in operation, and you need to make sure that those devices are not a security risk. They can be embedded system. They could be a security risk, but you can also have embedded systems in a device built in, such as embedded microchips, and those could be a risk, so you need to be aware of those. A patch panel is a panel, and let's just say that this is the patch panel right here. And what a patch panel allows you to do is you would have the server here, and then you would have these cables that would patch into the server, and then these cables go out to the endpoint devices. Power over Ethernet, or PoE. It's a standard for providing power to devices such as APs, cameras, or IP phones through a cable. A PoE injector can be connected to a cable, and a second cable is used to connect to a device that receives power from the injector. So you could have devices that receive power over the Ethernet. So you wouldn't have to have a plug-in for the power on the device. It can be powered from the Ethernet cable. You have cloud-based network controllers. A cloud-based network controller is a remote device used to manage network devices like access points and switches. 5.4, network cables. You're going to come across different tools in the networking side. You might have wire cutters or side cutters. If you work in networking, you're going to build a little tool kit, either a tool bag. I have a little tool bag where I have my different devices. I took a fishing tackle box and converted it into my networking toolbox. And so I have my wire cutters, my crimpers, my punch down tool, my connectors, things like that can all fit in there. You might have wire strippers for stripping wires, punch down tools for punching down wires, terminating wires into devices, or crimpers. You can have multimeters, tone generators, loopback adapters, Wi-Fi analyzers, cable testers. Those are some other devices that you might come across. Now, when we're talking about the cable types, you have twisted pair, coaxial, and fiber optic. Fiber optic takes special training and specialized tools to work with. I can tell you, in all my time of working in networking, I've never worked with fiber optic. It's always been hired out because it does take special tools that are expensive, and it does take special training. Coax cable is fairly common, especially when you're talking about doing cable or cable internet. And then twisted pair cable is common for small businesses, depending upon which version you're using. Coax cable is made out of either copper or aluminum. It's used in cable TV systems, satellite communication systems. It is harder to install, it's more expensive, and it's harder to troubleshoot than twisted pair cabling. It bends less easily, and so it tends to be a little bit more expensive, and it tends to be a little bit harder to install. But you have different types of connectors. You have the F-type, the BNC, and the N-type. Twisted pair, you have unshielded twisted pair and shielded twisted pair, or in the industry you'll hear people just say UDP or STP, and you just need to know which one's which. So shielded gives you a shield, and I'm just going to go down and talk about that. Shielded twisted pair, it gives you better protection against electromagnetic interference and radio frequency interference. It's more expensive and it's harder to install. The reason it's more expensive is because you have this braiding or foil shield, which protects the wires from that interference. So if you get a signal, let's say from a light, or it's too close to an electrical line, you have that shielding that protects that signal. On an UTP, or unshielded twisted pair, it's more common. It's less expensive, and it's not because it doesn't have the extra material shielding it. But one of the downfalls of it, or one of the weaknesses, is it's more prone to interference. So you got to be careful about where you're installing it. Now, when we're talking about twisted pair category ratings, the Cat 5 UTP, you used to have the 4-pair UTP. It replaced Cat 3. It's the most standard today is the Cat 5, and you'll see a lot of Cat 6 though as well. You had Cat 5, Cat 5e is very common, but you're going to see Cat 5. You will come across still some Cat 4 and Cat 3 in some older buildings, and you may have to replace it with some newer cabling. But the Cat 5e gave up to 1 gigabit a second at 100 megahertz, and Cat 6 gives you 1 gigabit at 200 megahertz. Now, you have the twisted pair schemes here. You have T568 and T56B. Some of the common questions I've heard about this before is, which version do you use? It really doesn't matter. They are both, either one can be used. You just want to check with wherever you're working with wiring to make sure if they have a standard or not, and you always want to work with the same standard with the same wiring scheme. So if you start with T568B, you want to stay with that as far as your wiring, and not install some wires this version and some wires this version. And in your documentation, you want to make sure that you're clear which version you used. Now, with fiber optic cables, you uses light to transmit signals. It's not affected by EMI or RFI, and you can also go very long distances with it. You have single mode fiber, which is a small core. It uses laser technology to send one beam of light. It can go over long distances, miles. And then you have multi-mode fiber, MMF. It's got a larger core. It uses LEDs to send light, and light is injected at different angles. So so here on the single mode, they're just sending a single beam of light. Here they're bouncing it, and they don't interfere with each other because they know which bounce they're using or which type of bounce. And so it's cheaper, and the bandwidth can be up to 10 gigabytes a second, up to 550 meters. And here's some of the common fiber optic connectors.